Okay, this video is going to be all about using the equations of motion. However, this time we're going to be focusing on vertical motion. And vertical motion is a little bit of a different story in terms of the types of values that we're sort of dealing with. So we're still using the same equations of motion we introduced in the last video, which is v equals u plus at, v squared equals u squared plus 2as, s equals ut plus a half at squared, and also s equals vt, but I do put that asterisk on that again, just recognizing that s equals vt is only usable for the constant or average velocities. So if we're looking at an example of what this might look like, I'm going to start off with a fairly basic one, although it's not really that basic, if that makes sense. So what we're going to say is we've got a ball which is going to be launched upwards with an initial velocity of 6 meters per second. It's going to go straight up, straight down, and the question I have for you is how long is this ball in the air? Pretty straightforward question. Now, again, probably something to note with these is that we are not including air resistance with these, and we won't be for any of the calculations we're making. So similar to what we did in the last questions, we're going to write down what we know, pick equations, and so forth. However, there are a couple of things to be noteworthy of here. Firstly, the acceleration in this scenario is 9.8 meters per second, and that's because it's a gravitational acceleration. And the other thing to note is that the velocity up the top here is 0 meters per second, and that's because the object has been going up, 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 and up, and then it's going to go down, 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 and down, and therefore there needs to be this sort of turnover point. So that's where the velocity up there is 0. The other thing I'm going to note is that when I'm doing these questions, I'm going to break them into a going up and a going down phase. All right, and we'll sort of become clearer why we're doing that while we're working through these questions. So if I focus purely on the going up phase for this first question, what I'm going to say is that u is 6, because that's what I've been told. I'm going to say that a is negative 9.8. And the reason behind that is that if I'm saying that u is positive 6 meters per second, and that's going upwards, I've already noted that gravity always goes down, and hopefully we know that. So therefore that is going to be negative. The other thing I need to note here is that the final velocity when I'm going up is 0. Okay, and that's because the final velocity of the going up phase is when we get to the maximum height. And the question that we're interested in is t. The other thing we don't know is s. So if I'm looking at it and I want to find t, I know u, a, and v. I can use this first equation here, v equals u plus at, and that will be enough information to solve it. So I go v equals u plus at. If I rearrange that for t, I get v take u over a, because I've been added by u and I've been multiplied by a, so I do the opposite of that. And therefore, if I sort of scroll down, v is 0, u is 6, and I've got negative 9.8. And that gives me a t value for time of 0.16 seconds. Now, what's interesting to note with these questions is what's actually happening in this scenario here is that the ball is going up, or the object is going up and then going down, and it is landing at the same height. Now, what you will find is that I can guarantee you will find you get the same answer for what we are doing here, 0.61 seconds to go down. If we want to prove it very, very quickly, what we would see is that u is 0, v would actually be unknown, really, for what we're doing, a would be 9.8, and then we could work out what's going on from there. Now, what you would need to do as well is you would have needed to find the height over here to match that over, and if you follow the equations of motion, you'll get 0.61 for the time. But simply what we can remember is that when we have an object going up and going down to the same heights, then we know that the time to go up and the time to go down will be the same, assuming it is purely vertical and not on an angle. So what that means is that for this question, the total time is actually quite straightforward. It's just 0.61 plus 0.61, which of course is 1.22 seconds. So that would be the answer for that particular question. Now, what we can see though, is that unfortunately that's not as simple as it gets. What there can be in other scenarios is questions where we have different heights that we're dealing with. So I'm going to say this time that the object is being launched from, say, a 10-meter platform. So if I say this is the object here, I'm going to say that again, it's launched upwards at 6 meters per second, and it's going to go up, 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 and up. But then on the way down, someone's sort of taken away that launch pad, and it's actually going to return down to ground level, which means it's falling an extra 10 meters when it's fallen down as opposed to when it's gone up. And that's why it's very, very important that we focus on these going up and going down phases, because without doing that, we'll see there's a difference in the results that we're looking at. So the going up phase, we've already sort of done this, but just a reminder, because we just literally did this before. We've got U equals 6, we've got A equals negative 9.8, S is something we don't know, V is 0, and T was what we were trying to find. We rearranged it for V take U over A, and when we did that, we got an answer of 0.61 seconds. Now, when I look for the going down phase, similar to what we were discussing briefly before, U is 0, V is unknown, A is positive 9.8 because gravity goes down and we're looking at an object going down, T is what we're trying to find, and S is unknown. Now, if you look at it, we've actually got way too many unknowns at the moment because we currently don't know V, T, and S, and that's no good. So the obvious one for us to find is S, because what we know is that if I can find the height that it goes up, then I just need to add that to the 10 meters to work out how far it's gone down. So I'm actually going to bounce back over here to this going up phase and find the S value. So if I do that, I can sort of pick a whole range of equations. I'm going to choose V squared equals U squared plus 2AS, but I could have chosen the other S equation and I'd still get the same answer. When I rearrange for this, I get V squared take U squared over 2A. And if I look at it, I get 0 squared take, what have I got there, 6 squared over 2 times negative 9.8. Now, when you punch those numbers in, what you're going to find is that that height is 1.84 meters. So what that's telling me is that this object went up 1.84 meters and it's already on a base of 10 meters. So when it's going to fall down, we've actually got 11.84 meters for it to do that. So now I've got a situation where I know U, A, and S, and I'm trying to find T. Now you could look through the equations to work out which one is going to be most relevant for you, and what you'll find is it will be this one, S equals UT plus a half AT squared. There is some great news straight away with this equation. The great news is that because U is equal to 0, we can forget about UT because that will be 0 as well. So what that means is I'm left then with S equals a half AT squared, and then I need to rearrange that for T. Now, there's two ways that this could look. Firstly, you could rearrange it and say that is root 2s on A, or the other way it could be is root s on a half A. The half kind of looks more familiar to this because that's what we've got, but that's sort of what we're dealing with. So if I'm just going to use this first one, remember times in by 2 on the top here is the same as dividing by a half, so that's really why they are equivalent. If I use that, I've got T equals root 2 times S, which is 11.84, divided by A, which is 9.8. We'll put those values in, and we get a time value there of 1.55 seconds. So I've now got a time to go up, there it is all the way over there, and a time to go down all the way over here, and the total time would just be a matter of adding those two values together, which would be 2.16 seconds. So you can see that clearly going up and going down are going to produce different times in this scenario because we're falling down further than we're going up, and the breaking them down into going up and going down is very, very important for those questions that are not starting and stopping at the same level. So hopefully that helps you with those.